Shri Gurubhyo Namaha, children. Welcome to our online teaching academy, Ekalaiva. Today we are going to learn 12th standard state board, chapter number 4, electromagnetic induction and alternating current. And in that we are going to learn AC circuit with capacitor. So this is the circuit diagram of an AC which is connected to a capacitor of capacitance C. Now the instantaneous value of the alternating voltage source is given as V is equal to Vm sin omega t, where Vm represents the voltage amplitude, omega represents the angular frequency, and t represents the time. So let us write this equation to start with. So V is equal to Vm sin omega t. Now here small v represents the instantaneous alternating voltage. Okay. Now we know that in first chapter in electrostatics we have learnt about the capacitance. The capacitance formula is given as C is equal to Q by V. So here Q represents, so what is Q? Q represents the instantaneous charge on the capacitor. So the EMF across the capacitor will be given as EMF across the capacitor will be Q by C. We know the formula for capacitance as C is equal to Q by V. So it will be V is equal to Q by C. Okay, now I am going to apply Kirchhoff's loop rule. So applying Kirchhoff's loop rule, that is the voltage rule. It states that the algebraic sum of the potential across any circuit. Now here you have a voltage, here you have a potential difference between the two plates of the capacitor, which is considered to be the EMF. So the algebraic sum of these voltages is equal to 0. So let me write this equation as V minus, we know the EMF of the capacitor is Q by C is equal to 0, or when I bring this term to the right side, so the minus becomes plus here, so V is equal to Q by C, or I can write this Q as V into C. I know the value of V to be V is equal to Vm sin omega t, which is nothing but the instantaneous voltage. So substitute here in this equation. So now Q becomes, instead of V I substitute Vm sin omega t into, bring this side C here. So the equation is Q is equal to C into Vm sin omega t. Okay. Now we know the definition of current. So by the definition of current, so what is current? I is equal to dq by dt, that is rate of flow of charges, is nothing but current. Now here I have the value of Q to be C into Vm sin omega t. So substitute for Q as C into Vm sin omega t. So substitute d by dt of C into Vm sin omega t. So this will be the equation. Now since this C and Vm are constant, let me take this out. So I will be C into Vm d by dt of sin omega t. So what is d by dt of sin omega t? So differentiate that, you will have the value of current to be C into Vm d by dt of sin omega t will be omega into cos omega t, that is d by dt of sine omega t is cos omega t. Again, when I differentiate omega t, you will have omega. So that omega I have brought it to the front. So the equation of I is equal to C into Vm omega cos omega t. This is the current equation, right? Now this is the voltage equation. Now I started with the voltage equation and I have ended with the current equation. Now I am going to compare this current and voltage equation. But before I could do that, now according to Ohm's law, we have the value of current to be I is equal to, according as per the Ohm's law, we have the value of current I to be V by R. But here we have Vm, which is the voltage, but we don't have any value for resistance here, but we have C and omega on either sides. So in order to bring this C omega into the denominator, I'll just rearrange this and write as Vm by 1 by C omega into cos omega t. Okay ma? And here one more thing. Now this is just a simple rearrangement, that's all. Okay, I wanted to have some term in terms of resistance as per Ohm's law, and I have the value of current already. So just to have a value, I just rearrange this as 1 by C omega. Now I need to represent this cos omega t in terms of sin omega t, because only then comparison will be easy. So cos omega t, I can write cos theta as sin 90 plus theta. Can I write like this? Yes, of course. So I will write I as Vm by 1 by C omega. I can write this cos omega t as sin omega t plus pi by 2. So 90 here, 90 plus theta, right? Theta is omega t. 90 I can write it as pi by 2. So I equation now becomes Vm by 1 by C omega sin omega t plus pi by 2. So this is nothing but you call it as instantaneous value of current. Okay, and we know the current equation I is equal to Im sin omega t. I have to write that. So what is Im now? I is equal to Im sin omega t plus pi by 2. So what is this Im? Im is nothing but Vm by 1 by C omega, which is called as peak value of AC. Okay, so this is my current equation. So equation number 1 is voltage equation, which is V is equal to Vm sin omega t, and here this is current equation, which is represented as I is equal to Im sin omega t plus pi by 2. Now I am going to compare these equations. Now from these equations we can understand that the current is leading voltage. So what is the phase angle between the current and voltage? Here it is plus pi by 2. So I can very clearly say that the current leads the voltage by a phase angle of pi by 2. This is in the case of a capacitive circuit. Okay, so current leads voltage by a phase angle of pi by 2. Okay ma? Now this is also represented pictorially. Now here we have drawn the wave diagram and also the phasor diagram for current and voltage equation. Okay, so let us start with first voltage equation. So we know the instantaneous voltage equation, V is equal to Vm sin omega t. Now in this I am going to substitute for omega t. Now since omega t is along the x-axis, this has to be completed. Okay, now omega t is taken along the x-axis, so we give different values of omega t here starting from 0. Here 0, then it is 90 degree here, then 180, 270 and 360. So omega t takes 0, 90, 180, 270 and 360. So we are going to give different angles. Okay, so let us start with omega t 0. So omega t 0, so substitute sine omega t 0. So sine 0 is 0, 0 into Vm is 0, so V is equal to 0. So when omega t is equal to 0, what is the value of V, children? V also is equal to 0. So that is the first point marked here. Now for the first part, we will take omega t along the x-axis and voltage along the y-axis. So V becomes 0. So this is the first point we have marked. Okay, ma? Now next we substitute omega t as 90. So substitute omega t as 90. So sine 90 is 1. 1 into Vm will be Vm. So V will be Vm. So where is the second point? Here. Let us assume a rough voltage. What is value? Suppose let us take it as 10. So I will start from here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just an approximate value, not the original value, just for approximation, just for marking, I am just telling this value. This is not correct value. Okay. So V is equal to Vm. This is the maximum voltage here. Right. Next we are going to substitute omega t is equal to 180. So 180, again sine 180, it is 0. Again 0 into Vm 0. So V is equal to 0. Again for 180 is pi here. So this is the third point. Now this is for 0, 0. Now this is for 90. Now 0 and pi, you have in the middle, you have the value of pi by 2, which is 90. So this is a maximum. The third point omega t 180, which is pi, for the voltage value is 0 here. Okay, ma? Next, omega t is equal to 270. So where is 270? It is between pi and 2 pi, this point. So omega t 270, what will be the value of V? Sine 270 is minus 1. So minus 1 into Vm will be minus Vm. So V is equal to minus Vm. So here this is 270. And here you will have approximate, suppose if I have taken here plus 10, so this will be minus 10. So you have the fourth point here. And again the fifth point is omega t is equal to 360. So V value sine 360 0, 0 and V is equal to 0. So here is the fifth point. So when I join all the points, this is the voltage wave diagram. Okay, ma? Similarly, so for all the values of omega t, when I plot the point, this is the curve for the voltage. Similarly, we write the same, substitute the same values for the current equation also. So let me write here current equation. What is the current equation? I is equal to Im sine omega t plus pi by 2. Right? Now here you should be very careful while substituting the values. Again you are going to substitute the same values what we did for voltage. Omega t 0, 90, 180, 270, 360. But here when you substitute, let us take the first value omega t 0. So omega t 0, what will be the value of current here? So substitute omega t 0. Okay, 0 plus pi by 2. Pi by 2 here is 180 by 2, which is 90. So 0 plus 90 will be 90. So sine 90 will be 1. 1 into Im will be Im. So the value of current will be Im. So here you should substitute the value and then add plus 90. But here it is not like that. You directly just substitute the value and just plotted the point. But here it is not the case. You need to add plus 90 to that. And then only you have to find the value of sine. So I is equal to Im here for omega t 0. So omega t 0. Now when you draw the graph with again x axis as omega t. Now this time y axis becomes current value. You will be plotting the values of current. So I here. So I is equal to Im. So the first point here. Now here for voltage we took 10, but when compared to voltage this is lesser. So let me take approximately as 8. This is not correct value, children, just for understanding I am giving. So 0 I, so this is the first value for current. So omega t 0, current is Im. Okay, then we'll go for the next value. Omega t is equal to, what is the next value, children? 90. So 90, so what will be the value of I here? So 90 plus 90, 180. Sin 180 is 0. 0 into Im will be 0. So I is equal to 0. So the second point for omega t 90. Omega t 90 is here, 0 and pi. In between you have pi by 2. But the current value is 0. So this will be the second point. Okay, ma? Right. Next. For omega t is equal to 180. What will be the value of I? So omega t 180. 180 plus 90 will be 270. So sin 270 is minus 1. So I have the value of I as minus Im. So where is 180 here? So 180 is here. Now respect to that you plot the point here. So this is the third value. Okay, ma? Right, next substitute omega t is equal to 270. 270. So I will be 270 plus 90, which will be 360. So sin 360 will be 0. So 0 into Im will be 0. So I is equal to 0. So where is 270? 270 is in between, here 270, but the current value is 0. Okay, so the graph will be continuing when you substitute 360 also, but we are not doing it. Okay, so let me see, omega t is equal, substitute 360. So I will be, now 360 plus 90, so you have to take it as sin 90, which is 1 again. Okay, so I will be, I am here, so you will have the next point to be here, which is not marked, but I am telling you where will be this. So this here you will have the next point, which is equal to this. So when I mark all these points for the current, you will have the current wave like this. Now from this itself it is very clear. Look at the starting point. Now as far as voltage is concerned, it is 0, but whereas it is current, it is starting from maximum. So this itself, now this line will be small in an extension to show that there is a phase angle of phase difference of pi by 2. So there is a dotted line there. So we can very clearly understand from this graph itself that there is a phase difference between current and voltage, and we can very well say that the current leads the voltage by a phase angle of pi by 2. Okay, ma, and here this is also represented as phasor diagram. Now here look at the phasor diagram. Now this is the voltage phasor, this is the current phasor. Now here is the voltage phasor where we have the value of OA to be the maximum voltage, which is given as Vm, and here this is a current phasor which is OB, whose maximum value is Im. Now what is the phase difference between these two? So as I already told you, current leads voltage by a phase angle of pi by 2. So what should be the angle between the voltage phasor and the current phasor? It should be 90 degree. And since current is leading voltage, you should have the current phasor in this direction, and the angle between them is 90 degree. Okay, so this is the voltage phasor which is given as Vm sin omega t, and this is the current phasor which is given as Im sin omega t plus pi by 2. Hope you are very clear with this phasor and wave diagram. With this we are going on to a very important thing as far as this AC circuit is concerned, which is called as a capacitive AC with capacitance. I am going to introduce what is called as a capacitive reactance. Okay, let me write here, children. So what is called as a capacitive reactance? Capacitive reactance, it is represented as XC. Okay, this is C, children. So it is XC. What is this capacitive reactance? Now we know the P peak value of current as, now this is the peak value which is given as Im is equal to Vm by 1 by C omega. Now let us compare this equation with the value of current in the resistive circuit. Okay, we have learnt about the value of current to be equal to Im is equal to Vm by R. Now this is the case of a resistive circuit. Now this is the case of a capacitive circuit. Now look at the value here. Now what is the value of resistance is R here. Here you have 1 by C omega. Now this 1 by C omega plays the same role as that of the resistance here. So this 1 by C omega is nothing but you call it as capacitive reactance. But why do we say here it as reactance? Actually here we are saying it is resistance, right? Resistance, which will resist the flow of charges, but here it is a reactance. So what is the difference here? Why do we say it as reactance but why not resistance here? There is a small difference here, children, because now as far as a resistive circuit is concerned, where you have only a resistor connected, now this resistor will not have any change in its value with change in frequency. This resistance will remain the same with respect to change in frequency. But whereas in the case of this capacitive reactance, now whenever there is a change in the frequency, since we connect an alternating source, now as far as alternating current is concerned, this alternating current change its direction for every half cycle. So we talk about what is called as frequency. As far as a resistive circuit is concerned, if there is any change in frequency, this does not have any change. But whereas here, if there is an increase in frequency, definitely this will react. That is why you call this as reactance. So how it will react? Definitely there will be a change in this value. Okay, so that is why we call this as capacitive reactance. Okay, and this capacitive reactance, it is measured in ohm, the same unit, like how we measure the unit of resistance. The capacitive reactance is also measured in ohm. Okay, now let us take this value alone, children. I wanted to tell you something very important about this. Xc is equal to 1 by C omega. Okay, now omega is nothing but, the formula for omega is 2 pi f. Okay, f is the frequency. Substitute. So when I substitute, Xc is equal to 1 by 2 pi f omega, means C. Now f represents frequency. Now all the other values are constant. 1, 2, pi, C, everything is constant. So which alone is varying here is f. So I can write Xc varies inversely to the frequency. So greater the frequency, lesser will be the reactance. So this is a very, very important conclusion as far as an AC circuit with a capacitor is concerned. So the capacitor reactance, it varies inversely because frequency is in the denominator. So it varies inversely as the frequency. Now this is with respect to an AC. But when you compare this with DC, as far as DC is concerned, now there is no frequency as far as a DC is concerned. When you connect, instead of AC, you connect a DC, you connect a battery. Like how you have connected an AC here. Instead, if you connect a DC, what happens to the value of Xc here? Since we do not talk about frequency at all, so the Xc value will be infinity as far as DC is concerned. So I can substitute Xc is equal to 1 by 0 because f is not there for a DC. So 0, so Xc becomes infinity, which means as far as a capacitive circuit is concerned, it offers infinite resistance. infinite resistance to the steady current, which means you cannot a capacitor, it will not allow DC to pass through it because of its offering of very high resistance or infinite resistance, because XC becomes infinite here. So it will not, a DC will not allow, a capacitor will not allow DC, it allows only AC to flow through it. Okay, you have many more complications in this, but as far as our topic is concerned, we will come to a conclusion stating that a capacitor blocks DC. There will be a 3-mark question like a capacitor blocks DC but allows AC. Explain. So in that case, you are supposed to write this formula: XC is equal to 1 by C omega, substitute omega is equal to 2 pi F, and say that XC is inversely varying with frequency, and as far as DC is concerned, XC offers a very high resistance, so a capacitor will not allow DC to flow through it. So this is the thing you should explain when it is asked as a 3-mark question, children. Okay, so this is about AC circuit with a capacitor connected to it. This comes as a very important 5-mark question. Okay, so we'll be continuing with an RLC circuit in the next video. See you children for the next video.